Welcome to Martin's Institute of Teaching. In this video, we're going to be going over linear equations using the integrating factor. And when we're going to solve these linear equations, we need to have the equation in this form: y prime plus p of x times y of x is equal to q of x. So we also need to get the integrating factor, which is integrating factor I is equal to e integral of p of x d of x. So let's go ahead and jump into this to show you what we're going to be doing. So the first thing we're going to do in order to solve these is we actually need to get the equation into the proper form. Looking at this equation, we already have y prime plus 3, which this is going to represent your p of x, and t plus e to the negative 2t, that's going to represent your q of x. So we actually already have the equation in the correct form, the way we need it. So after that, after we have it in the proper form, we want to get the integrating factor. After we solve for the integrating factor, we're going to multiply everything by the integrating factor. After you do that, you're just going to integrate both sides of the equation. After you integrate both sides of the equation, you're just going to rearrange everything, and then you're pretty much done. So let's go ahead and do those steps. So here, the integrating factor, p of x is equal to 3. So we're going to go ahead and substitute that in. So we're going to say the integrating factor is equal to e integral of 3 dt. So if we integrate 3 dt, we're going to get e is equal to 3t. Now normally you would put plus c because this is an indefinite integral, but when we're getting the integrating factor, you don't use the plus c here. So this is our integrating factor, e 3 to the t. So now that we have that, now we're going to multiply everything in this equation by e 3 to the t. So let's see, we're going to have I times y prime plus I, or the integrating factor, times 3y, which is going to be equal to I, the integrating factor, times t plus e to the negative 2t. So now we're just going to sub in this, we're just going to swap out the I for the e to the 3t. So we're going to get e to the 3t times y prime plus e to the 3t times 3y is equal to e to the 3t times t plus e to the 3t times e to the negative 2t. So now let's go ahead. So here, this left side, now all we're doing to, if you did this correctly, well, here, let me show you. So you're going to actually just for right now, just write the integrating factor times y. So the integrating factor is just going to be e to the 3t times y. Now, if we did the integrating factor correctly, if you take the derivative of this with respect to t, you should get this right here. So why don't we try that? So first, let's see if we get this part right here. So if we take the derivative of this, of e to the 3t times t with respect to y, you're just going to get e to the 3t and y prime. Now, if we take the derivative of this with respect to e to the 3t, well, you're just going to get e to the 3t again, and you're going to bring down the 3t, and you're going to take the derivative of that again, and just to get 3. So you're going to end up with 3 e to the 3t times y. Maybe that didn't make sense. Here, let me show you. If you're doing this through the product rule, I'm just going to write it right here. So the first thing is you're going to take the derivative of the first one times the second one. So this would be e to the 3t. You want to take the derivative of that times y, plus, now you're going to do it with the derivative on the second term. So it's going to be e to the 3t times y, but you're taking the derivative of y. If you take the derivative of y, you're just going to get y prime. If you take the derivative of e to the 3t, you're going to get 3t e to the 3t times y, but you need to take the derivative of this because of the chain rule. So that's just going to end up being equal to 3 e to the 3t times y. which is what we have right here. So that's how you do that. Let me go. Now I need the space in here, so I'm just going to delete this. But now you see where that comes from. And that's a good check too, just to make sure that the integrating factor was done correctly. Because if it's not done correctly, you're never going to get the, it's just not going to work out. So now, I'm going to say equal to, well actually if we integrated all of this, this is actually what we're doing. You're actually integrating this whole term to get this, but that's why you do this and just do the product rule, because it's usually easier than trying to do the integrating all of this. So now we're going to need to integrate this side as well with respect to dt. So now integrating this side, one thing we need to do is, well, let's go ahead and rewrite this so it looks a lot neater. So let me write the integral of t times e to the 3t, that's just this term right here, plus, no, I can completely separate them or I cannot. Yeah, let's go ahead and separate them. Maybe that'll make it simpler. I'm just seeing. So this is going to be dt plus the integral. Now here you have e to the 3t times e to the negative 2t. Now since these are have a common base, you could just add the tops. So what I mean is if you have e to the x times e to the y, that can be rewritten as e to the x plus y. You just add them. And in this case, since you have 3t and a negative 2t, you're just adding them two together, and you're just going to get t. So this is going to be e to the t dt. Instead of using integration by parts, let's use a nicer method. So let's say let's use tabular integration. So let's see, tabular integration, you can use that instead of using integration by parts. The way you do it is you take two of the terms, both of the terms, you're going to take the derivative on this side, and you're going to integrate on this side. So doing that, we would get, let's see, the derivative of t is just going to be 1. Take the derivative again, and you're going to get 0. Take the, now on the right side, we're going to integrate. So if you integrate e to the 3t, you're going to get 1/3 e to the 3t. If you integrate again, you're going to get 1/9 e to the 3t. And so now we're going to multiply that into that. It's going to be a plus and a minus. So that's going to be equal to t divided by 3 e to the 3t minus 1/9 e to the 3t. Okay. Alright, so this will take care of this part. So now, let's see. So now we're going to get e to the 3t times y is equal to, now we're going to write down all of this. So we're going to get 1/3 times t e to the 3t minus 1/9 e to the 3t. And now when we integrate et, you're just going to get e to the t, or you're going to get et again. So this is going to be plus e to the t. Now we are going to add the plus c. So now, at this point, now we can just, now we're going to need to rearrange everything, because now we've integrated everything on over here on the left side and everything on the right side of the equation. So now, let's see, so we're going to divide everything by e to the 3t to simplify, and because we want this in terms of y only, so we say y is equal to, now e to the 3t divided by e to the 3t on this side is going to cancel it. We're going to divide it here, so it's going to cancel that. We're going to divide here, and it's going to cancel that. We're going to divide here and here. So let me go ahead and write that out. We're going to have 1/3 t minus 1/9. Now when you divide, when it's e divided by 3t, that can be rewritten as e to the t minus 3t. So that's going to actually be equal to plus e to the negative 2t. Here, again, you're dividing c by e to the 3t. divided by e to the 3t. So that's going to end up with plus c times e to the negative 3t. And that's actually how you solve this problem. So that's the general solution to y prime plus 3y is equal to t plus e to the negative 2t. Yep. So, all right, that's the first one. Let's go ahead and do another one. Okay, so now let's do another problem. Here we have 2 times y prime plus y is equal to 3t. Now, remember, we wanted to have it into a certain form, right? We wanted to have it in the, so look, we want to have it in the y prime plus p times y equal to q in this form, which is the exact same thing as saying y prime of x plus p of x times y of x is equal to q of x. So we want to have it in this form. Now unfortunately, when you look at it here, we have it in 2 times y prime plus y is equal to 3t. Now here you have something in front of the y prime which we do not want. We want the y prime by itself. So we have to divide this, or we have to do something just to get rid of this 2. And what we're going to do is just divide everything by 2. And that's going to give us y prime plus 1/2 y is equal to 3 halves times t. So now we have the equation in the proper form. And so after we do that, now we want to solve for the integrating factor. And if you recall, the integrating factor is equal to e, the integral of p, in this case it's going to be p of t, so p of t dt. So since here we have 1/2, we're going to get e, the integral of 1/2 dt, which is going to be equal to integrating 1/2, you're going to get e to the 1/2 t. Now remember, here you're not going to put a plus c because this is just for the integrating factor. So this is our integrating factor. Now after we solve for the integrating factor, we have to multiply it into everything in this equation. So let's go ahead and get started on that. So it's going to be I times y prime plus I times 1/2 y is equal to I times 3 halves of t. Okay, so now let's just replace the I with e to the 1/2 t. You're going to get e to the 1/2 t times y prime plus e to the 1/2 t times y is equal to e to the t divided by 2 times 3 halves t. Okay, so now we've multiplied everything by the equation by the integrating factor. So now we need to integrate. So if you recall from before, if you did this correctly, you're just going to get the integrating factor times y. So the integrating factor is e to the t2 times y. And again, we can check this. So first thing is you're going to take the derivative with respect to one, and then you're going to add that to the derivative of the other with respect to the other. So let's take derivative of e to the 2t. So you're going to get, well, let's just do it all. You're going to get e to the 2. You need to take the derivative of that times y. If you take derivative of this, you're going to get, that's going to be equal to 1/2 e to the t divided by 2 times y. Now we should get this. Oh, we don't get that actually. Oh, look at here. 1/2. So when I did this part right here, I actually forgot to bring down the 1/2 here. So let me fix that. Yeah, you got to pay attention to those. They're very important. So this is y. So yeah, we actually do get it. So 1/2 e to the t divided by 2 times y. So it's 1/2 times e to the t divided by 2 times y. We get that there. So now we want to take the derivative with respect to the y prime, but oh yeah, don't like how that looks. So let's turn this into a t. Okay, so now if we do the derivative of this, but with y, all you're going to get is just e to the t divided by 2 y prime, which is e to the t divided by 2 y prime. So, whoops. Okay, so we're getting that. Now let's go ahead and just, since we've confirmed that it's correct, we're going to go ahead and delete this. Don't need it anymore. Don't need that either. Okay, so now we're getting, now basically we've integrated this side to get this. Now we're going to integrate the right side of the equation. So we're saying the integral of e to the, let's write that better, I don't like to like that. So let's put 3/2 t e to the t divided by 2. So again, I'm going to use tabular integration. You don't have to, you can use integration by parts. I just find tabular integrations a bit quicker and neater. So first thing I'm going to do is I'm going to kick this 3/2 out. Well, don't forget dt. So I'm going to rewrite this as 3/2 the integral of t e to the t divided by 2 dt. So in order to use tabular integration, we're going to use t and e to the t divided by 2. So we're going to have t, and then we're going to have e to the t divided by 2. Remember, on the left-hand side, you take the derivative. On the right-hand side, you integrate. So the derivative of t is 1. The derivative again of 1 is 0. Now we're going to integrate on the right-hand side. So the integral of e to the t, you're going to get 1/2. Actually, no, that's going to be 2. So you're going to get 2 times e to the t divided by 2. You're going to integrate again, and you're going to get 4 e to the t 2. So now we're going to multiply that into that. That's going to be a plus. Multiply that into that. That'll be a negative. So you're going to get, okay, so now that we've done the tabular integration, let's write that out. So we're going to get, whoops, I can just see it actually. So we're going to rewrite this out. We're going to get e to the t divided by 2 times y is going to be equal to 3/2. And now you're going to write t times 2 e to the t divided by 2. That's going to be positive, so it's going to be 2 times t times e to the t2. Next one, it's going to be a negative, so it's going to be 1, or it's negative 1 times 4 e to the t divided by 2. So it's going to get negative 4 e to the t divided by 2. Now let's not forget to add the plus c at the end. So once we got that, I'm just going to go ahead and multiply this 3 divided by 2 into the whole thing. So we're going to get e to the t divided by 2 times y is equal to, multiplying this into here, you're going to get 3t e to the t divided by 2 minus, let's see, 4 divided by 2 is 2 times 3 is 6. So you're going to get negative 6e to the t divided by 2 plus c. Now at this point, we want to get rid of, we want to isolate this y, so let's go ahead and get started on isolating the y. And you're going to get y is equal to, since I'm dividing everything in this equation by e to the t divided by 2, it's going to get rid of it here. It's going to get rid of it here, and it will not get rid of it there. Instead here, it's just going to be divided by e to the t divided by 2. So it's going to be 3t minus 6 plus c times e to the negative t divided by 2. And just so you know, if you ever have, let's say, like an x down here, you could always rewrite that as x to the negative 1 because it has a positive exponent here, so that just shifts it up to the top like that. That's all I'm doing. And that is your equation. This is the general solution to the linear let's see, what was that one? Kind of forgot what it is. Let's see. Oh yeah, it's the solution to y prime plus 1/2 y is equal to 3/2. So let's see. Yep, there you go. So this linear equation, the solution to this linear equation is y is equal to 3t minus 6 plus c times e to the negative 2t. So I hope this made sense, and I hope you enjoyed the video. If you did, don't forget to click like and subscribe. So, alright, good luck in your guys' classes.